Hello friends, hope you're doing well. In today's video, we'll be talking more on queue algorithms. In the previous video, if you recall, we have gone through the stack algorithms and also its implementation. So in the same way, first we will cover the algorithms in the queue and then we'll move towards implementation. So let's understand how queue works and what are different algorithms that are related to queue. So first let's understand what is queue and how it is different from the stack. So as you can see in the picture, you can relate queue with any other queue that you see in the real world, whether it's a car queue in the parking, whether it's like people queue in any of the shopping store, or any other queue that you can think about. So if you try to put queue in contrast to stack, you can understand that unlike stack, it follows first in, first out. So any in this example, as you can see in the car that first entered in the queue will also be going out first. So in other words, you can say it follows the first in, first out philosophy. You can also say last in, last out. That is also true. So any car, in technical word, any data that came in the last will also be going out in the last. Okay. Now coming to different methods that are important for queue. So like stack, even queue has some of those methods, though the name has been changed here. So for insert, if you recall, in stack we call it push. Here we call it enqueue. For the removal of data, in stack we were calling pop. Here we call dequeue. And again, make empty is like clearing out the members. So it is similar to stack. Some of the properties that you can think here, for example, top, that was peak. Peak is used as a common term in both stack and queue. Is empty, again, it will as the name suggests, it will return true or false based on whether queue is empty or not. And same goes with full. Okay, let's move further. Let's look at queue a little more closely. So as you can understand, here we're talking more of like technical, like how queue will be implemented. So as you can see, if you try to relate from previous example, here we were talking about cars. So here basically there are different data. Data can be of any type. So if you look at data, as you can see, they're in a kind of chain, and we are saying that right hand side is kind of data is going out, and from left hand side data is continue to come. Okay, so this is other way to represent how the queue works. In the below diagram on the same slide, you can see that how enqueue and dequeue works, and also you can see that there are two pointers. You can call it variables as well. They are pretty much used in the queue to represent from which end we should be dequeuing the data element, and from which end we should be enqueuing it. So front pointer is a pointer that, as you can see, kind of goes in the top, goes in the top. Here is basically right side. So it's keep changing basically when any new elements are added. So it's keep changing basically. So any new element that you can see is added, it will add in a left side, and it will basically increase the counter of rear. And if any element is getting dequeued or removed, the front pointer will be adjusted accordingly, so that rear and front both represents the element. So basically rear represents the first element in the queue. You can see relate from the left side of the corner, and front represents the topmost, or you can say the rightmost member in the queue. So front keeps that the pointer on that element. So if you refer to front, always it should give the rightmost element, and if you take the element of in the rear pointer, it should always give you the first element. This is how this technically plays out. Okay, moving further, let's look at the complexity part of it. That is very important in any data structure. Before we start using them, we should be aware about what complexity they bring in. So here we're talking specifically for time complexity. So as you can see, if we implement, let's try to handle array first. So as you can see, in queue is given as a O1. O1 is a, you can say, fastest time complexity one can think about. So it is like, constant complexity. The reason why NQ has NQ has a complexity of O1, because when we add the element, we just kind of keep adding it. We don't really tend to adjust the element. So hence it is kind of given as a O1. So irrespective of the member, we don't need to adjust the pointer, and hence it is O1 is a constant time. If you look at DQ, it is ON. So ON, folks who understand complexity, ON is basically means that it has a correlation with number of element in that queue. So what this means that based on the number of element, the complexity will be determined. So why it is like that? Why we are saying ON here and not the O1? The reason is that when we perform DQ operation, we don't just remove the element, we also try to adjust the order so that order is maintained. And to adjust the order, we really need to traverse the element, and hence we are saying that DQ takes ON, right? And this can be further improved or you can say optimized when we use linked list. So if you try to implement queue with linked list, then you could achieve both operations in queue and DQ using O1, because you don't need to really loop in linked list the way you otherwise need to do in the array. Okay. Now let's move to different algorithm that comes in queue and try to understand how that works. So as you can see, if you recall the pointer, because pointer's understanding is very important here. So look at the front. Front is an element that is in the right side of the in the spectrum, and that keeps the element. You can say the element that came that came in the first in the queue, right? So that is the front. Rear is something that is keep adding. Sometimes we call it rear as a back as well. That keeps the track of the element or data that is inserted, the alias. So it is like new elements are going into rear, and the existing element are keep pushing in the right side, and front is keeping track of the first member that came in the queue. So front and rear are understanding. So if you look at, again going back to the procedure, so if you want to understand that what is the peak is what? If you recall the definition, peak means that give me the element. In stack we are saying that the top element, right? In queue it is not a top element, rather it is the element that came first in the queue. And if you recall this first element that will come, that front takes care about the element that came first in the queue, and hence we are returning front. So return queue, queue will have all the members. So if we try to have the index of front, it will give us the rightmost element in the queue, or you can say the first element that came in the queue. So that is about getting peak. What is full? Useful is, as the name suggests, it will give us true or false based on whether Q is full or not. Whether, or you can say, in other words, if Q has got into, the situation where it can't accommodate any more members. So basically, if it is kind of touching the max size of the queue. So max size as an element especially used when you're talking about array, because array can't be flexible by nature. So we need to define the size of the array if you are implementing queue using array. So you need to define what is the max size. And if your array kind of got into the max size counter, if it is matching with max size value, it means that it has already added the element that it could adjust or it could manage. So it is, in other words, it is full. So if it is full, we will return true. And if it is not matching with, or it is less than, you can say, max size, it means that it can accommodate more members, and then we will return false. So that is how this is full works. Is empty. So if you look at the picture again, so rear will keep exceeding rear will basically will have the element, or you can say pointer of the the first element, and front is keep kind of changing based on how many members or how many data is added. What if both are like matching? So both are matching, it means that, what it means that it is empty. So initially, when the queue addition queue is kind of, you can say, initial state, there is no member on that queue. So in that case, if you look at the picture, both rear and front will have the same data. So if they are same data, means none of the element has been inserted. So it means that it is empty, right? So if both are same, it is empty and we will return true. If not, if rear has gone further, means or you can say front in this case. So because front will have keep adding the value. So if both are having different values, then they are not empty. So you can return false. What about in queue? So in queue is, as you understand, it is to insert the data. So if is full, you will call the same routine that we described here is full. If it is full, of course, you will return that queue is full. You can't accommodate any more members. If not, then you will increase the counter of rear. Here you may be wondering that why we are increasing the counter of rear. The reason is that we are implementing queue with array, and array by nature is not, it's not both ends open, right? So we are trying to mimic the behavior of queue using array, and hence this technical implementation that we are increasing the counter of rear, that may give you that why we are increasing, because rear is supposed to keep this first element. So we are doing because we are trying to implement the behavior of queue using array, and hence to mimic the behavior we need to increase the count. So if it is an queue, the counter of rear will be increased, and it will keep having the data as we add into the queue. So that's how this in queue will work. Once we look into the code in the next video, you will understand that how we are able to mimic the behavior of queue using using array. Same goes with TQ. If it is empty, you will pop the message that it is empty. If not, you will kind of basically you will take the member of the front, because that has the latest like first data that came in the queue, and you will increase the counter of front. These are some of the differences that you can, if you want to explore more, you can look into this. This little bit about me. If you want to follow me on Twitter, here is a handle. And if you think that these videos are helping you, you may want to subscribe it. Thanks for your time.